Hello, guys. Very good morning from sunny Sydney, Australia. Today, I'm going to introduce you to this new research which provides you disentangled 3D scene generation with text prompt. This is a new methodology for generating 3D scenes disentangled into their component objects without supervision. It is better described with demo instead of telling you in words. So let me show you. This is their project page and you can see the entire scene in the video at the moment. If you click on these 1, 2, 3, 4 numbers, let me click on 1. You only see mouse here, so mouse has been disentangled from the entire 3D scene. Click on 2. This is sort of the bench. 3, it's a hat. And 4, there is another object. Now at the same time you can see that there is also disentanglement in forms of normals and also in the uncolored ones. Let's check another example. Click on this prompt, or chicken hunting for Easter eggs. This is the entire scene. Click on 1, only the basket with the eggs. 2, chicken. 3, these are the eggs, and at the same time normals and the uncolored one. And there you go, the fourth one. Now let's see a bear wearing a flannel camping and reading a book by the fire. There you go. So this is a bear. Click on 1, and then it is also disentangling or decomposing it into different objects here. How cool is that? And then there are a lot of other examples scattered throughout this. Now this method optimizes multiple neural radiance fields or nerves, each representing a separate object, and composites these objects into the scenes that are encouraged to match the distribution of images generated by the text to image model. This approach, termed layout learning, also demonstrates that new capabilities in text to 3D content creation and really, I think, outperforms current methodologies in various ways. They also have this PDF paper, so you can read more about it in the abstract and on the right hand side by downloading this PDF. Now, another great thing about this whole scenario is that not only they have shown this, but also this method is simply out of this world, and this is how it is working. In this one, in very simple words, but they are doing it. They first introduce a simple tractable definitions of object as portion of a scene that can be manipulated independently of each other and still produce valid scenes. Then they incorporate this notion into the architecture of the neural network, enabling the compositional generation of 3D scenes by optimizing a set of nerves as well as a set of layout for these nerves. Then they apply layout learning to a range of novel 3D scene generation and editing tasks, demonstrating its ability to disentangle complex data despite requiring no object labels, bounding boxes, fine tuning, external models, or any other form of additional supervision. How cool is that? Now, method is quite simple. To bridge the gap from monolithic 3D representation to scenes with multiple objects, they have introduced this more expressive 3D representation. So they learn multiple nerves along with a set of layouts, which in other words means that valid ways to arrange these nerves in 3D space. And then they transform the nerves according to these layouts and composite them, training them to form high quality scenes as evaluated by the STS loss with a text to image prior. This structure causes each individual nerve to represent a different object while ensuring that the composite nerves represent a high quality scene. And there are a lot of other things, around use cases. For example, look at this. So in this one, they are building scenes around object. So for example, the asset is grumpy cat here, and then the prompt is a cat wearing a Santa costume holding a present next to a miniature Christmas tree. So cat is the main object, and the same time we have normal and uncolored. And if you go to the objects, the first object is this gift, two is the Santa costume, and third is your Christmas tree. But the main object is cat. So we have these separate disentangled objects which they have been merged with that main asset. Similarly, a cat wearing a Hawaiian shirt. So this is a cat. Main object is cat, and then there are different objects like uh, this glass with drink, and then this. I think this that is just sort of a seat or something with the glasses. Similarly, if you go to sports motorbike, this is you can just say a line in a leather jacket which is riding the sport motorbike here. How cool is that? And then of course you can separate out the objects. Amazing stuff. And similarly, another use case could be separating a nerve into objects, which is sort of a reverse thing. Now, in this one, the prompt is that a bird having some sushi and cake. Now, if you click on these, the bird is separate, and this bowl is separate, and then this sushi is separate. At the same time, you can see that on the right hand side there are normals and uncolored. Similarly, two cute cats wearing baseball. There you go. Now, there are two types, as I mentioned earlier, original and reconstructed. Original is this. If you click on reconstructed, this is a reconstructed one. How cool is that? Amazing stuff. And by using the same methodology, you can also automatically arrange existing objects like this. And what is happening here is that you can see the asset is spaghetti, chair, and table. And then we are allowing the gradients to flow into any layout parameter while freezing a set of provided 3D assets. So at the very end, this is the learned layout with the chair, table, and this one. How cool is that? And similarly, if you check out the rubber duck and vase table, so it has combined and automatically has arranged the existing objects. Now another use case could be sampling different layouts, and in this one you can see that these are all the learned layouts. Similarly, if you check out the robe, a pair of slipper, and a candle, it has rearranged it as after learning it. And there you go. So this is um, analysis and ablation here. Ablation is quite an interesting and big notion here. Ablation primarily refers to a process or technique used to systematically remove or modify parts of a model or algorithm to study the impact of these changes on the model's performance or the outcome of the image manipulation. This term is quite heavily used in these sort of model, and as you can see in this example, prompt is a backpack, a water bottle, and a bag of chips. And then similarly, we have this a slice of cake, and then there are different model variants like learn k nerve, it produces this, and then plus learn one layout is this, and layout is this, and then per object STS is this. How cool is that? So these are all discovered objects. And then there are few limitations too, which it is discussing here. For example, there's it also suffers from a bit of a Janus problem. A Janus problem is quite interesting one. The Janus problem is like trying to solve a puzzle where you have to meet two opposite goals at the same time. It is named after a two-faced Roman god because it involves looking into two different directions or trying to solve two different things, and trying to make a design that achieves two things that might not easily go together. Like for example, in this example, you can see that um, if there are objects which are moving together, it sometimes arranges them in an undesired way. And these are few of the example as you can see on your screen, like a monkey and a whiskey, and as you can see, it is not moving properly. A ninja slicing, it is not doesn't look that good. And then two fancy llamas enjoying a tea party. It also doesn't look that uh, good in the directions. So that's it, guys. I will drop the link to this paper in video's description. Try it out. Let me know what do you think about it. I think awesome stuff. I couldn't find any code as of yet. When I do, I will also make a local installation video of it. So really hats off to all of these researchers. Great work from Google Research and UC Berkeley. Thanks for watching. If you like the content, then please consider subscribing to the model. And if you're already subscribed, then please do me a personal favor and share it among your network as it helps a lot. Thanks for watching.